Okay, thank you very much for coming to my session. My name is Reinhard Blumauer. I'm CTO from IP and e-marketing software in Vienna, Austria. And I welcome you very much here to this session. It's going to be pretty exciting. I had last year a little test run, to be quite frank, doing microcontrollers with Xojo, and it was a great success. And thank you so much for that great feedback I got. And basically, that's why I trashed everything. Because it was obvious, the stuff I had last year was just kind of a little test run, plug and playing with microcontrollers. And I found out that this is not good enough for you folks. So I had to reboot the whole thing. And actually what we did is we had new developers and two gifted C++ guys and a couple of hardware guys. And we created everything from the scratch. We created a new operating system, and it was just amazing going there. And I'm very honored to show you for the first time in the whole world something real exciting, and TipControl 1.0 of 1.0, and with an including mesh network, and it's going to be really exciting. So thank you. So let's go on with it. Microcontrollers are everywhere, we know that. You know, I was speaking before, and the cool thing is, if you start looking at it, they're really, including your toothbrush, they're all over the place. And we know, of course, cars and security and all the things we have here on the list. Now, one thing we need to know about microcontrollers are not computers in the sense of, they don't have an operating system like Windows or iOS or Mac OS X. We had to write an own operating system. And to take one of those chips, which we have here right now, the most important thing you need to know is just how to interact with one of those chips. And you have analog inputs, digital inputs and outputs, and you have various connectivity which we use in order to put our attachments or caps, which we call it, onto it. And the most important thing is that you understand what is digital, analog. I mean, analog is pretty much going from 0 to 100, and digital is high-low. And then you have certain intelligent interfaces, which we call I2C and SPI. Now, this is a development from Xojo developers for Xojo developers. So because we were thinking of you folks. And, you know, Xojo is just an awesome program to develop programs. And it's very simple. And that's what we were thinking of, is how to make hardware just as simple as Xojo is. So not going deep inside and doing all these C++ and Perl and C libraries, and it takes you forever to just get a cool functionality. So what we have done is we developed that all for you. And let me introduce you to TipControl. It's the real hard stackable thing. It's, you stack it up from one to another, and on the bottom you have the microcontroller. On top of it you have little caps, and these type of caps are pretty simple because you just stack them on. Even if you do put it on the wrong way, nothing's going to happen. So there's nothing what you can do wrong. Now what you want to do is you want to talk to those caps and those microcontrollers. And we had here a few wonderful things. The first is, like as I said earlier, the stackable stuff. And then within, on the bottom, you see the microcontroller. We created an operating system. It's called OSMU. And this operating system takes care of all of it. So once you start talking to it, the operating system delegates it to the caps and executes the functionality. There are a lot of stuff you can hook up on. I mean, there's so much out there, you know. You have all sorts of sensors and stuff you can hook up on. So you're not only it's not only required to just have stackable things. You can really put anything on it. And then another thing is we have a simulator software. This software is interacting with the hardware so we can make it easy. And it will be a drag and drop simulator, and at the moment you right away see the results. Then we have, here is that the microcontroller at a glance. We have here ESP32. It's actually a 32-bit fully scaled microcontroller. It has its memory inside. It has its RAM inside. It has pretty anything inside than any computer has, just a little smaller. And we have it between 160 and 240 megahertz. It depends how much energy the microcontroller should use. So we have various energy-saving modes, so some of the stuff can even run for years. And the connectivity are pins. We have 40 of those pins, whereas 34 you can use on your own choice. It includes Wi-Fi, it includes Bluetooth, and of course it has USB, which we call UART. Now here you see plenty of third-party sensors, gas sensors, ultrasonic sensors, infrared sensors, displays. I mean, the lot you can have here. And if you're not that familiar with stacking it, putting it together, then we have it here stackable. And those are those little caps I call, and I have some already here. This is the stuff here, and all you do is you put it together, just plug and play it, and it's already with a battery cap on it, and it's full functionally as such. All right. Now, and there are hundreds of different caps and connectors, and we produce some of them to your needs. Now, the next thing is, what do you need to know in order to program hardware? Basically, very little. You should know Xojo and know a little bit about voltage, so the difference between 3 and 5 volts, which isn't all too difficult, and especially what you want to do. You want to do some analog, you want to talk to the caps analogs or digital, or more intelligent sensors. They talk, and protocol is called I2C or SPI. This protocol gives is a very hardware closed protocol, which you are able to talk to intelligent sensors, not like an LED is an actuator basically, and it's high or low. Now, TipControl simulator is in Xojo written software, and that software enables you to talk to the hardware and configure it. Now, it's actually based now on MQTT. MQTT is a protocol transferring very little data from point A to point B. It's quite fast, but it's still based on TCP/IP. And it's a standard, an industry-done standard. So you will have the opportunity talking to other microcontrollers once you have programmed it your way. You can set your variables and test right away the functionality, which I will show you in a second. And another cool thing we have here, in this new version, you can create events. Events are things when something happens on one cap, you want to have a result, or you want to calculate something through a macro and send it then back to your server or to your own program, which is an MQTT server, to receive this information. Now we have a network and message designer, and of course you can back up your configuration, and that's what's coming up now shortly, is upgrading the operating system. Because once we permanently develop new caps and put new drivers in and put new technology in, so it's important to get in the possibility of an upgrade. Now, let me go into a demonstration here. Now, I hook one up just so you see the logs, but actually you don't need to hook it up as we communicate through Wi-Fi. Now, here we see already one of those guys reporting. This is one of the programs. And on the right-hand side, you see some of those sensors which we have available. Okay, we can make it a little bigger. And those are those little caps. I can take that off. And stack, let's say, just for the start, an LED cap on it. All right, now we want to get that little thing. This is on the bottom here, we have the microcontroller. Then we have the battery cap. On top of it, we put some LED. Now we have the option here. Let's say we take an RGB, and we just drop it over here. And here we can configure the pins, on which pins it hangs. I mean, there's documentation to know, but you can choose pretty much any pins. And we have defaulted in here, and we say save. And now we have that. And now you see it's becoming red here, and becoming yellow, and more green, and we put more blue in it. That was damn simple. You know, I mean, basically, that's it. Now, last year I had it connected on USB, if you remember. This is no more necessary. The USB port is basically for one simple reason here, actually to get the log output, which I will show you what all the data coming out of the log. But basically, that was a very simple thing, how to control on an analog. That is basically analog because I can change the intensity, and I can, of course, turn it off. Actually, I can put it over here on the table then. Now I can just take that off, that cap, and put another cap on. Let's say we put that on it. And I know that this has the same pin as the thing, as the one lamp I had here. So that's why it was already making noise. And this is a really beepser, which we have on for instance, on our gate control. If you press the right button, then it says beep, and you can enter. So that's pretty cool. So now we can take that off, and as you see, I do it all without disconnecting the power. So it's very simple. Now we have another thing which is pretty cool. And this is called, you make usually your LED strips with it. All right. And let's see, where is this driver here? Here it is. This is something for the LED strips. You probably know those LED strips. You know, you can have a mile long, and you have several LEDs with multiple colors. And the cool thing on that, you can address each individual LED. And you can make really posters and stuff like that, which is called Neopixels. And now, let me try another one here, because we're going to run here. And let's give it a red or yellow and say OK. And here we are. Here's the yellow. And now we can have it a little run. And let's say make it outer color and run LED. And here you see it's going to kind of flashing around here. And this is basically controlled by Xojo. You know, the Xojo application actually is sending the information to the microcontroller, and the microcontroller is telling it to the cap. So this is actually where Xojo controls it. There's no intelligence really now into the microcontroller, but this is how you control it at the moment through the Xojo. Now, we can stop that. And now I have another little thing here. I guess this is this box. Now, Bruno, a good friend out of Canada, and you were already guessing right here. You know, we were talking about electric cars and stuff like that. And electric cars are pretty neat, you know, and Bruno was making it for his kids and stuff, where he can sit in there and stuff. And so we were thinking, okay, we need to make a motor controller. So in how simple it is to set up a motor controller, I want to show you here right now too. All I do is a cap. I take this cap off, put another cap on, like this one here. Actually, we should need some wheels. Then I drag, look for my motor driver, which is this icon here. Put it over here. It's already default configured. Actually, there are two engines you can control. You can set if you want to have forward and backward, or just forward. And we simulate here one. I'll show you then later on a little more in detail. The other, so the right control would just be gas, and the other one will be half is forward and the other half is back. This is the one, we actually put it, you will see it afterwards. This is the motor which goes slow and back, and that's the other one, forward and rewind. And this is cool. You will see it anyway later, because I have another demonstration here, because I think that's the boring stuff. So anyway, that doesn't have wheels, so it won't be driving, maybe flying, but not yet. So let me turn this off, and let's disconnect that again. So that's pretty easy, you know. I mean, you just take one of those drivers, and you just drag and drop it, and you have a couple of configurations, and off you go. And actually, Xojo is still controlling it. So, now actually that concludes my session, and now let's start with the show. So the cool stuff, of course, is mesh network. Now, mesh network is a total new thing we implemented in TipControl, which makes the thing very, very powerful. Now, all of the controlling right now, actually the laptop did. The Xojo program did it. Now, how about configuring a remote control? How about configuring other things in a mesh network with Xojo and controlling not only one microcontroller, controlling many microcontrollers, where they interact? Now let me show a quick introduction to that, how the communication is running. Now, the physical stuff is Wi-Fi, Bluetooth, or USB, or UART, as you call it, as we call it. And on the internet side, also the outside world, which like the world talking to my laptop, is TCP and MQTT. Actually, last year I didn't even know what MQTT is. One of you guys was a lot smarter than me and said, hey, this is the protocol you should take care of, and because it's a quasi-standard. And that's what we did. And so the outside, you talk to the outside world or to the cloud. We have a special cloud service as well, where all the sensors and actuators report to. And that uses TCP and MQTT on level 0 to 2. The difference between those 0 and 2 level is just if you get a feedback from the server that the server understood that information and send it back. Yes, I got it. And are you sure you got it? That's level 2. We start with level 0 because level 0 is a little faster. And if you don't get that message, I send it again. And the other thing, which is the most exciting stuff, is the stuff how other chip controls talk with each other. And that needs to be real time. And I mean real time. MQTT is fast, but not fast. You couldn't fly a plane with it. You couldn't have a control like we had here last day on the boat, you know, with this DJ drones. I mean, they communicate also in one or another way, and they communicate in their own protocol, which is not TCP based. We use a protocol called ESP now, which is a protocol of the hardware manufacturer we made a deal with. So we had to decide, okay, which microcontroller we use, and we looked around which is the ideal one. So we are with Espressif, which is a company in China, and it's pretty cool stuff what they bring up with. And then in order to communicate, we had to create another messaging protocol. And the messaging protocol is what information goes from one tip control to another, and how this information runs. Now, the cool stuff is you can connect multiple tip controls together. All right. And you can connect multiple networks between each other, where multiple tip controls are. And then, of course, you have a lot of caps. Each microcontroller has a lot of caps. And so each cap can talk to another microcontroller far away and talk to his cap. So, I mean, this is just getting amazing. And then we have special cloud services in case you want to have nice graphics. It's not online yet, but that's going to happen. So you can have all the action of the caps reported to the cloud, so in a graphical nice interface and play around with the information. And then you can connect any MQTT server. So if you're a fan of Raspberry has something called Mosquito. You put the Mosquito MQTT server, TipControl will be able to talk to them. What you're going to do with your data is then finally your choice. And we have a free Xojo MQTT server because we wrote one for the simulator, for that simulation program. We had to write an MQTT server, of course. And there is actually two plugins, one MQTT plugin and one TipControl plugin, which was very easy to control. And this MQTT server, actually, we will give away for free. So everybody who is interested in making their own applications talking to hardware, I will make it easy for you at no expense. And then what I said, Mosquito is a MQTT server for Linux, Unix, and so on.
Sort of Raspberry Pi?
Yes, Raspberry Pi. Actually, a lot of people use Raspberry Pi we have it in our company. Raspberry Pi, as I say, it's the brain, and these are the slaves, and they report. But you know, you have to know what you want to do. So I prefer to, because I'm a Xojo programmer myself, I wanted to be an MQTT server, and I want to get that information, want to make a decision, and send my hardware according to that, whatever my program is doing. I want to introduce then the hardware to do that and to do that. You create caps on the fly, you can delete caps on the fly, also the drivers on it. So it's very dynamic through the messaging protocol. Now, let's look at the dimensions of those things. I mean, this is really shocking. First of all, one tip control, one of those devices, you can hook up to 18 other devices. Only 5 if you want to have it encrypted. So for speed purposes, so no one can listen in. Then you can put, at the moment, 99 caps on each one. That's going to be a pretty tall tower, but you can hook them up to 99 of those. And then you have 5 levels of guys can talk to. So that guy talks to that talks to that, but you never talk directly to that. Yeah? But eventually you can have 5 levels. So in that amounts to a stunning number, to 2.5 million tip controls you can connect. That's unbelievable. You probably won't use that many. And just because those 5 levels are those 5 hops, let's think of a router. So you go there, and then you go to the next router, and the next router, and the next router. So you actually don't see your destination. But that's what actually it is a chain of mesh you can do. This is not the limit, really, but that's what we have it at the moment. Now, if you hook up that 99 caps, so you have 250 million sensors. I mean, that's quite a lot. Most likely you won't need it. And then you can, at the moment, have 8 individual networks. Now, if you use a Mosquito server, then he routes to other networks. So this is just our internal routing. So but if you have a Mosquito server, then you send that information there and it routes it to who else is subscribed to it. So that's unlimited, really. Now, let's go into the real messaging system. Now, in order to address one of those, we have something called the locator string. Now, the locator string has these 7 digits, and the first digit is actually the network digit. Between 2 and 6, it's the level, and the last digit is your cap. So whenever you send something, any information from point A to point B, you use this locator string because you want to say, I want that tip control over there and cap number 7 at network 0. So this is a kind of an IP address philosophy, if you wish, but that makes it easy because you create messages, send it over there, and it finds its way to its destination. And then we have only two different types of messages itself. The one are system type of messages. Those are messages if you want to delete caps or you want to have some information about your memory or you want to, I will show you then later on, those are just system-oriented messages. And the other one are driver messages, when you talk to the caps. So each cap needs a driver. And we program the driver, and the driver is in our operating system included. So every driver, every cap we sell will automatically have its driver included, which is part of the operating system. Now, let's look at a practical case. And I have 2 cases here now. One of them is the weather station. A weather station we created it that way. You see on top, you see the outside world. This is the simulator, the cloud, or any MQTT server like Mosquito. Then we have it in the device location A, we have a display telling you the weather conditions. And then we need the sensors doing all that. And we have a cap with temperature and barometric and humidity, and then the other thing, we have, let's say, wind speed or stuff like that. And let's have a look at that, what that's going to be about. So, kannst du das mal kurz halten? So that's a display, and that display is called Nextio. What the cool part on this display is, you can just simple configure it like anything, any cap. And the funny part is, if I put here the battery, then you see here a little sample of TipControl here, and I can put it maybe here on the table. And let me put that. That's a sensor. Now, in the moment I put that sensor on, now it's, of course, not livable, this information, but now we have real data. So I just plugged it in. They communicate with each other and in a rhythm of 2 seconds. You can program that on your own. Now we have another thing, like this, so I put that over here. Now we can make a test how good your lungs are. There's a battery inside. There should be a battery inside. I have it. Okay. Oh, okay. It's definitely charged. So, and everything is mobile, and it's talking to each other. Now, of course, if I should change, and here we have the wind speed on the bottom. So if you basically see 1 meter per second, And you see the temperature rising and falling, and we actually have a neat thing here too. And as you see, this is all mobile. You know, there is nothing that's all driven by batteries, and it talks to each other. There are actually three microcontrollers. One is the display, and here we have a battery cap and the Bosch sensor, which actually has a pressure. It has actually is a gas sensor as well, and it has altitude, because we have here a QNH reading. As a QNH comes from the flying, but it's hectopascal. This is the pressure we have right now, and therefore you can calculate altitude. So obviously you don't see it doesn't make so much of a difference, but that's pretty cool. Now, and as you see, the wind speed and all of that changes immediately. Now, this is what the neat part is. We have 3 microcontrollers and 3 caps, and they talk to each other autonomously. And you can configure them because you just talk to the master. Because as we had here, if I reverse here that system here, we had here a master device location A, which is the display, and it talks to the simulator, so you can configure it through the simulator, and the other devices, you really don't have a contact with them, because you talk to the master, and the master tells the slave what the informations are all about. Now, the cool thing on the next-gen display is there's a special software running on Windows, and you can simply make your display the way you feel like. Look at it. And then wherever you want data, you give it a field of your choice. And that field, you enter into the simulator and say, this value should be at that field. That's all you need to do. And that's what we did here. And that's why I really appreciate it. And actually, you can take that sensor. I mean, as you know, microcontrollers don't like water. So I put it in a little bag and wrap it up. And I have here an ice bucket. And that's where I'm going to put it. So, and you will see if you wait a few minutes, then you see this temperature dropping. So, that is one of those examples of what we can do. And actually, those devices can be pretty far apart, a couple of 100 meters, and in that configuration. Now, you can add a long, let's say, antenna to it, and there are special devices, 4 antennas, and then you can go as far as any router goes. And then we are actually working on other frequencies like UHF and stuff, which is another cap, using another product, also the same protocol, which we use, but that goes miles. Miles, and I mean miles. And actually, if you want satellite, no problem. I fix your satellite communication as well. So the sky is really the limit. It just depends on you folks, and because you can do anything. Now, let's try something else to see interactive, quick and dirty. To see how fast the thing goes, I have a little demo here too. And I'm using 2 chip controls. Okay? Now one is the master and one is the slave. And whenever I just programmed that all with Xojo, you know, just say, okay, if I press the button, then beeps and send the guy over there, I want the next LED. So you hear and see how fast it is. That's faster than anything, so you can control any drone with it, no doubt about it. Any car or anything like that, because it is so fast. So whenever I press, you hear the beep and you see the change the light. So we can walk down there, it goes quite some distance. Yeah, please. So let's go and have a little walk. It's pretty cool. And here you see, and that's a simple demonstration showing you how fast the communication between those two devices is. I use blue, but you can use any other color. Thank you, Christian. Now, and at the end, I have another cool stuff for you folks. So those things here. Now we have 3 microcontrollers. And on top there's a little called Potentiometer. You know, this is like, you turn it, you know. It's actually, it's another shield, you know, to just put it in. It's actually nothing else, it's analog in, you know. It's nothing exciting. And so those are those guys. And here, we have that little car, what we've seen before. I plug here the battery as well. So here we are. So now we got to wait a second. And then they're going to, they also talk to each other. And if I know which one is left and right. It drives pretty much like a tank. Oops. I'm not that. It's a little gadget. Oops. Thanks. Just put it up. I think I have it the other way around, right? Oh. So, and basically what that shows you, it's a live control. And it's working instantly. So, all right, that's so much to that. So let's continue. So it's pretty cool stuff. So basically what you can do with it, you can make live controls. No, it's okay. Yeah. No, basically we're done on that. No, whatever. No. Now, let's go to the business aspect of it. And it's $1 trillion market. And microcontrollers, as I said, they're all over the place. And you should get into it. And you find them, and there's so many applications to go for. Now, let me tell you what the next steps are, what we're going to do. One thing, you see, it was really working, and I'm excited for myself that everything was working, not like last year. But one thing what we couldn't get ready was an automatic upgrade of the operating system. Since we practically daily have a new OS coming, we need, before we ship, we need to get that fixed, that in our TC simulator, you will have the option to upgrade the operating system. You will be able to download it in the cloud and upgrade your microcontrollers. Now that will come shortly. Then, of course, we want to improve our messenger system, how to create more messages and easier messages, and also the events. Because here we had a lot of events inside, so if that is above 50, then have the LED red and green and move the wheel forward or backwards. So those are actually events. There is no microintelligence inside, it's just simply events. Then, of course, more drivers on demand. And this is where you come into the game, because I want you to tell me your possible application. I'm willing to develop in a flash anything, what you can think of. I mean, of course, there are limits of money and time, but basically, we have the operating system in a matter finished that it will be easy for us now to adapt new drivers and new sensors, no matter if they're I2C, SPI, or what every kind of gateway they require. Then there will be a special macro builder coming up. Now the macro builder is actually the real cool stuff too. And it's like you give your hardware own intelligence so that they make decisions based on informations what the caps send, or there are other microcontrollers in their caps. Whenever each microcontroller can make its own decision and react accordingly. That will be in the macro builder. So we'll take a lot of that shall be a graphically interface, but we also will have a kind of a simple programming. And basically everything out of that, including the macros, the events, anything you can program directly out of your Xojo. Anything. Because the communication between the caps and the different devices is just a messaging building system. And we just create the message and send it on the road. And then, of course, our cloud services. The cloud service will be important if there will be a big, huge MQTT server. And everything you can do on Xojo, eventually you should be able to do on the cloud as well. So you just plug it in, and it will report to the cloud. So when you go with your iPhone, and you probably see a few TipControl with some numbers on it, if you look at the network, then there's a little web server inside, and that little web server lets you configure where the master controller is talking to. Either it's talking to your IP on your laptop, which was in that case, or it will be talking to the cloud or to any other MQTT server of your choice. And of course, documentation. Documentation is also the thing. We aren't quite there yet, but I presume in a couple of months we have it. Actually, maybe less in a couple of months, we have all the documentation. For that stuff, we have now built in official. Now, shipping ready. Of course, last year I was talking also about shipping. Now, I didn't ship one. And the reason being is, as I say, I didn't feel comfortable shipping you anything where I believe there is more stuff coming. And you know, I couldn't get it over, so that's why I said, okay, I don't ship anything. I rather build it good and I make it nice, and so you guys are happy. And then I don't want to have 100 phone calls. Ronnie, that thing doesn't work. That thing doesn't work. And nobody is happy. You aren't happy, and I'm not happy. But the official distribution will be expected at the European Xojo conference in Cologne. I will have a bundle of stuff here. I'm going to be a little watch dealer, pick and choose. And so if you're there, I definitely will sell it. But I wouldn't be on this conference for you, and I want to have something special really for you folks. Between August and September of this year, I will ship to some selected people. And I ask you kindly to go on to my website. There is a little survey. And if you're one of the selected developers, then I will give it to you for free. I give you a TipControl for free, a battery pack for free, and I give you, it depends what you write on that a survey, I will try giving you the necessary caps so you can play with. This is totally free, and if you do it now and before you guys leave, I have a little caps for you, and I give everyone who qualified a cap so that you know that you don't forget that you have a cap. Yeah, just go to the website, tipcontrol.com. I have just limited, but just go. If you really want to fill out the survey, that's the only thing I require, because I want to know what you want. Because I'm in that stage, I pretty much can do anything. And give me your business case. Give me your dream. Oh, I would love to do that. I mean, I can't shoot you to the moon. Man, I can give you the electronic for that. You know? But basically, that's what I would be happy if you could do that for me. And then I will send it to you or whatever, if you're in the States or in Canada or wherever, I just post it on my expense to you. So that but the only thing is I like a feedback out of that and what you have done or not done with it. All right, that's it actually. I'm done. And of course, now the questions. Go ahead.
What do you expect the typical price range of
Yeah, actually, the price range I can't give you exactly, but I can give you a hint. We try to have it, one microcontroller with the OS and certain licensing with it shall be around $49. And then you will have a few caps to it. They depend, they go from $5 to $200. I mean, there are some sensors out there they use at SpaceX. I mean, they cost $20,000. So, I mean, I'm sure I can control those guys too. But that's what you need to tell me. You tell me also what your business case, if you have already a sense of vision or philosophy, then you write it down. If you don't know which sensors to use for that thing, let me choose the stuff for you. But basically, I try to do it on a cheap way, you know. I mean, as cheap as possible, you know. But there's a lot of software quality inside. There's a lot of time involved, but I think that's going to be about $49.95. No. This is not what I'm thinking about. So if you ask me now how much the other tip controls cost, I can't tell you right away, but it's not going to cost $49. Now, if you want to make a mesh network of 2 million, believe me, I'm not going to sell it for $49.
2 million, maybe not.
But we find a solution. I'm almost certain we find a solution. I don't want to take your cash out of the box. I want to see you successful. Because if you're successful, I'm successful. Good question. Actually, I'll be very honest with you. I don't know. I should repeat. What protocol it goes for and what's the bandwidth. I can't really tell you exactly because we haven't tried out anything. But we have tried out a little artificial intelligence stuff with camera recognition for our event tools. That really works perfect. But it's 320 times 240 or something like that, what the screen size is. And we haven't used the maximum yet, but I believe there is enough. I don't think we can do HD. As a HD quality, I don't think it's possible yet. But, you know, this is the present thing. I don't know what's going to happen shortly. Go ahead. How long the battery life lasts? Well, actually, those stuff is 500 milliamps. Okay, 500 milliamps, and this display is just an energy sucker, so that's gonna leave right away. But usually, I use only 500 milliamps because they're small, they're tiny, they're not very big batteries. You know, just to tell you, that's about the size it is. Okay, and the tip control has 3 different ways to operate. And one is the high speed with 240 megahertz and full in action. Then it takes about 100 milliamps, 80 milliamps. Then we have some so-called low speed mode, which is 160 megahertz. Then we come down to about 30 milliamps per hour. And then we have something, a sleeping mode, and that divides in various things, which uses only 1 or 2 milliamps. And then you can wake it up with a cap. So a cap has a certain action, and it wakes it up. It's basically, if you let it stay, then suddenly it's going to take only about 5 milliamps without any speciality. Oh, well, we haven't implemented yet, but please put it on your wish list, and then I'm sure I look it in and I give you feedback within days. So just on TipControl, please put it down, and I will have a look at it. But at the moment we don't. Go ahead. Can you connect it to a TC power supply? Yes, of course you can. There is actually a cap, a TC cap available. Just please put it in your request sheet, and it goes for, I think, 9 to 12 volts, any power supply, and you have the standard jack, and you can run it with that without battery. Yeah, of course, we have that available. Yeah. Do we have an interface for Alexa? It's already in process. Okay, and because we are very excited, and exactly that's what we want to do too. And so that's a voice recognition, and I guarantee you it will be most likely available this year.
Okay, cool.
Go ahead. Yes, what are the APIs? There are two plugins. You just put it in your Xojo app, and the one is called MQTT, and the other one is called TC. Let's see where we have that. So here we are. I guess that was that one here. Yeah, here you see. Actually, I use only 3 plugins. The one is for the database. We have some special database stuff here. And the one is the MQTT message plugin. That's the plugin you create an MQTT server, a full-fledged MQTT server. I will give my stuff open source away. And then you have that TipControl plugin. And with the TipControl plugin, you can access all drivers and all messages. You create messages. And basically, I can show you here very quickly here too. If we have it here, like on an example of a control out, you see here, basically, you create a new TC driver class, and you say, and you put to it which driver you want to use. Then you create a message class, and you say you want to write something. Yeah, and you say you want to write something, then you use TC write. And the funny thing is, you need to know what parameters you need to give along that the thing works, which is very simple. You just get a dictionary out of that TC message, and that dictionary is going to show you then what you need to fill in. And in case of analog out, it's just one value, the value we want to put into it. But basically, it tells you already in a dictionary, once you use TCM message dictionary, then it tells you according to the driver you configured, and according to the write or read statement or whatever statement you use, it tells you already how do you need to fill the dictionary in order to have a successful message. Then you put that in, like for instance, how do you put the coordinates in it? Basically, you just let's say for instance a stepper motor. You know, and you have, let's say, you want to control 3 motors at the same time, then you have an X position and Y and a Z position, and most likely that's, if there would be an own driver for it, of course, and then you will be required to fill out in that dictionary those 3 positions. So if you look at the dictionary, it will tell you what you have to do. So, you use which chipset? For each individual, so which chipset I'm using, and yes, each chipset needs a driver. Okay, and if you say, let's say the motor driver, the TM6612, needs an own driver because we need to communicate with the inside and we need to get out, and that you will find right here in the TC plugin. Yes, exactly, and we can have a look at here if you look, let's say TC driver here, and you press the tab button. Then you see different drivers, the wind wheel, then the VLX, that's the distance measure chip. So each chipset needs an own driver, and it needs to be programmed by us. And then we figure it out for you that you have a simple interface, and you can handle it that way. Yes, go ahead. Yeah, how events created? Well, very simple. Also, you create it by the code. and you can say, if an event of a cap occurred, then do that and that and that. And basically you create a message again, a standard message. There's a message builder inside. And that message builder, you attach to the event. And you have a couple of events, rising above, falling below, a timer event, and change. If something changed, a value changed, then you activate more or less the event. And then executing is that message you created. That's the execution stuff. And therefore it goes to any cap in the mesh network. Go ahead. Yes, I'm implementing home control systems. Yes, we want to use the one from Apple at the moment. You know, that's the you have on the iPhone. So that's already in the pipeline. And please put it in the survey, and if you have that wish, then we have a look into it, and we definitely would like to do that. Any more questions? Oh, we are over? Oh, I'm sorry about it. All right. Thank you very much.